Hello everybody. So we will start with the file system forensics. Actually, it's chapter 3. And firstly we have to define what is file system. File system term, what is it? All the storage devices that contains personal data should have the file system. The file system is defining storage and access ways of data. Okay, so when you create any file on your host, this is stored at any place at the disk. So we have to ask that question: how operating system should know the exactly place of that file? So when you try to access that file after some time, the operating system should know the exact place of that file. So it means we need file system for knowing that place of that files. Okay, so here is the slide: the operating system using file system to access the files. Okay, also the user is here, right? We are using operating system to access the files. This is the working logic. Also we have some terms we have to talk about it. And before starting to talk about file system details, we should say something about terms like track, sector of a track, cluster. Okay, let's say unit value of HDD is bit. Okay, one bit could be 0 or 1. When the 8 bit come together, we call it bytes. The one character or number is 1 byte on the disk. It's important. Okay, so and after that 512 bytes is a one sector. We called one sector. It means 512 bytes. Okay, so here is the slide about that terms. We say sector, the B, this one. When the sector comes together, we call it track. Okay, so track is the A in here. It's a circle on the disk. Do you see that? Also there is one more term. Its name is cluster. Cluster is not constant value, so we can define it with different values when we are trying to format the disk. Also, cluster is an area that can write data. So how can we define cluster size? We will going to check that. But now, okay, you are familiar with this slide. Actually, we talked about that, but one more time we can say the one disk could contain more than one file system, could contain more than one partition, right? So we can divide our disk to partitions. Let's say the first partition could contain Windows operating system, the second one the Linux operating system, the third one could be used for storage, right? So maybe there is nothing, there is just file. So it's possible. Okay, we talked about cluster size, allocation unit size and cluster size. So what is it? Here is a good slide. Actually, it's a mind map. So we will try to explain how is it working. Let's say we have a file here, file 1, and its size is 80 bytes. Okay, so we are trying to write that file to our disk, and its disk formatted with NTFS file system, and our cluster size is 4 kilobytes. We defined that before formatting our disk. Okay, so when we try to write that file to our disk, this file actually reserving 4 kilobytes on our disk. So it means you can say that we have almost more than 3 kilobytes empty area on our disk, right? So okay, there's nothing to do about it, that's a fact, but we can change that size, cluster size. How can we do that? Let's check. Okay, here is my disk. It's a USB. Let's check it. It's NTFS. Do you see that? When I try to format that disk, here's some options. Capacity, okay. The file system, I can use some of them. And allocation unit size. This is actually cluster size, guys. So if I try to select one of them, and this disk will divide with this size as a cluster. Okay, so in here, in this sample, it's a 4 kilobyte. So someone format that disk with this option, right? Okay, I hope you understand that, and let's continue. It's a quick tip actually. Here is a slide that shows us some details about the terms. When I try to create text file with 1764 bytes size, like here, okay, I can see that information on size fields here. It's normal. But when I check the size on the disk area here, I see 4 kilobyte in here. So you got it. Why we see that size? Because the cluster size is 4 kilobyte in here. So even our file is more than 1.5 kilobyte, but this operation reserving 4 kilobytes on our disk. Okay. So I can show that. I can show that with the hands-on sample. Okay. Let's save this file as a sample file. Okay, this is the properties of this file, sample file properties. So you see that its real size is almost 2 kilobytes, but it reserved almost 4 kilobytes in our disk. So let's check what we have. How can we use this area? Okay, we have another two terms in here, allocated sector and unallocated sector. If any area on the disk marked as allocated, there's a file information on that area. It means that, okay? And when user tries to create a new file on the disk, this area cannot be available for that file. So operating system says that it's full. You cannot use this area for new file. Please try to find another place, another unallocated sector. Unallocated sector is a place that be available for data storage, okay? So here is a quick tip. We can find deleted files on unallocated area. Actually, recover tools scan in this area to find deleted files, okay? Allocated sector and unallocated sector. And there's a new term in the slide. It's a select space. Let's talk about it. Let's talk about slides in here. We have sectors in there, right? Do you see that? The first one, second one, third one, and fourth one. We have 4 sectors in here. And okay, so if we have 4 sectors, and let's say one of them size is 512 bytes. So we have our cluster size is 2 kilobytes. Do you see that? 1, 2, 3, 4. And someone tries to write data which size is bigger than 2.5 sector size. One sector is full, second one full, and third one is full to until half of them. Okay. So what will happen on that empty areas? Here and here. Here is empty. The rest of half use sectors called with RAM select. Where is it? Here, RAM select. Okay, why we call RAM select? Because file system writing random data to that area. Okay, here. So if you're lucky, you can find some passwords. You can find some important files in here. And here, the file select. And the last sector, which is empty, called like file select. Do you see that? It's totally empty. And this area can contain files from before writing operations. Okay, so let's say think like this: 2 days before this operation, and I read data with 3 and 3.5 sector size. Okay, so 1, 2, 3 and half. it was full until here, okay, and the last sector was used. But now I'm trying to write, after that I deleted that file, so these sectors marked as unallocated again, so it means it's available for new data operations, writing operations. And I try to write data with 2.5 sectors, so it was the sectors was marked unallocated, but there was a file information in the inside of these sectors, right? So I tried to write new file, and okay, this one overwrite it, the second one overwrite it, the third one also a little bit overwrite it, but here and here and here was allocated, but there was a file informations coming from the before, okay, not the second one, not the last one. So the last sector still contains some part of the first file. Actually, the recovering tool is doing that job, okay. It's trying to scan all the disk areas for unallocated sectors and tries to find file from the before operations, okay. Okay, now we are going to start with NTFS, but I can say something about FAT. The most known file system for Windows are NTFS and FAT actually. FAT is not so skillful and it's used on small removable medias, so that's why we are going to focus on NTFS. And maybe I can say something. FAT file system records activities with system time zone, okay. So NTFS file system records activities with UTC time zone. This is important for forensic actually. So when you are trying to combine your artifacts, evidences, you have to think about that information. And the NTFS, New Technologies File System. So it's used for Windows NT and newer versions. So you will see that file system in almost all Windows operating system versions nowadays. And what's its features? It's actually more reliable and more complex and more storage area and also easy to manage, so that's why the new operating system using this file system. And there are some kind of features. This file system is more reliable compared to others, and it has some features to check operations to find is it correct or not. And it has journaling features, which is really helpful for forensic analysts. It means when you try to understand what happened in one time period, it's X file, sample file, opened, extended, or deleted. So NTFS file system can provide this information to you. So because of that, it's important for us. Also, it has ADS feature. It means alternate data streams, and we will talk about it later with details. And more, maybe volume shadow copy, you know it. So the most of ransomware operators, attackers, tries to remove that volume shadow copies, right? You know it because it takes copies of some kind of user activities, user files. So, and you can go back easily with using this skill feature. And also, if you want to get more information about NTFS file system, I can advise File System Forensics book from Brian Carrier. I read that book, so it's really good actually. I can advise it. Okay,